saw your answer, it's correct. So you can share your screen, right, and start to answer your or present your answer to question number 2 from last week's class. All right. Okay, group 2, I leave it to you to do it. Okay. Meanwhile, while group 2 is trying to put up their presentation and deciding who is going to present, I want to show you something. Okay, can you see this? All right. Now, this is a coffee coaster, which is 3D printed. Okay, and that is actually a caffeine molecule. All right. Now, I have 2 of these coasters. Okay, I have 2 of these coasters. And at the end of what do you call our class, all right, 2 person who has been very supportive and very active throughout the class will actually get this coffee coasters. Okay, so this week I will actually send them by mail, by courier to Dr. Gallo. Okay, and then you still have this week, next week to be more active in class. All right, and we will see who's the 2 person who's going to get it. I will announce on week 8. All right, before your test. Okay, Ken? So group 2, can we have your members to present now? Right, just choose 1 person. Group 2, please present your answer.
Ya, dokter.
Okay. First, Doctor, can I speak bahasa?
Sure. Ken.
Jadi, yang ditanya itu kan pertama, the rate equation dengan formula R sama dengan K konsentrasi ClO2 pangkat A dikali konsentrasi OH- pangkat B, di mana masing-masing konsentrasi telah diketahui, sehingga untuk pertama kita mengcompare dari eksperimen 2 dengan 3. Kita masukin inisial rate-nya, kemudian dimasukin konsentrasinya, sehingga didapatkan masing-masing dibagi 1/2 sama dengan 1/2 pangkat B, maka nilai B sama dengan 1. Terus yang kedua, mengcompare yang eksperimen 1 dengan 2, caranya sama, masukin the rate equation sama konsentrasinya, kemudian diperkecil masing-masing mendapatkan 1/2 dan 5/7 pangkat A, kemudian diperkecil lagi dengan di-ln kan, maka ln 1/2 sama dengan A ln 5/7, sehingga didapatkan A sama dengan 2. Maka A dan B sudah diketahui, sehingga the rate equation, the rate is K konsentrasi ClO2 pangkat 2 dikali OH- pangkat 1. Untuk pertanyaan selanjutnya, the rate constantnya atau K-nya itu tinggal dimasukin semua rate-nya, kemudian konsentrasi ClO2-nya, terus kemudian konsentrasinya dan A dan B-nya, kemudian dipindah ruaskan, selanjutnya dihitung sehingga didapatkan K-nya adalah 278,26 mol min 2 dm pangkat 6 S min pangkat min 1. That's all, I think, Doctor.
Okay.
Thank you so much.
Nusaiba. Yes, all correct. Huh? So all of you can also refer to the answers which are available in the Padlet, right? Okay, this is correct. And what I want to say is during your exam or your test, so this is how you actually should be answering your questions, okay, step by step. Okay, just like how group 2 have done here. Okay, all right. Thank you so much, group 2, for presenting. Okay, good job. All right. Okay, so today we are going to go into another new part. All right. Okay, part 4, as I would call it. Now, before we go further into part 4, what I want to brief you first today is, if you had a chance to actually go through the notes for part 4, you will find that we are actually talking about only first order, right? Okay. Now, in this part 4 of the notes and today's lesson of week 6, what we will be covering in this chapter will be, how do you want to find the integrated rate law, all right, using the integration method, all right? So you will be learning about or trying to remind back what you know about the integration, and also what do you call your logarithm rules and so on, all right? Okay, now that is the first part for the first order reaction that we will be looking at. Then the second part will be another method which is known as the half-life method. Okay, so the half-life method will also, we will be focusing specifically on first order only. Okay, so for today's lesson is only on first order, but two different methods, which is the integrated rate law method as well as the half-life method. Okay, so please be clear about this because in the following week, we will learn the second order for the integrated, as well as the half-life for the second order, as well as the zero order integrated and half-life for zero order. Okay, so that will be next week. So today is first order integrated rate law and also the half-life method. Okay, so earlier we already learned the initial rate. By initial rate, we learned for zero, first and second order, already finished. Okay, all right. So if that part is clear, we can go into today's lesson. Now, going into today's lesson, before we start about what we want to be learning about the integrated rate laws and how you want to calculate and so on, all right, I want to draw your attention to remembering, okay, a little bit on the integration, okay, and how do you do integration, okay. So when you have a constant and you integrate to dx, all right, so it becomes ax plus c. Now, ax plus c, the c here appears, all right, only when there is no numbers here, okay, it is empty. So if it is empty, then you have to plus c, all right. But if you were to integrate from one number, let's say you are integrating x equals to 0 until x equals to 10, right? Say for example, in that case, then your c will not appear. Okay, so just bear that in mind lah, because later on you will find that in your questions for this chapter, we will actually have integration from one particular level to another level, all right, for all the what do you call question, right? Okay, but in general, this is how it will look like. Okay, so now the next one, if you integrate a variable x to dx, all right, okay, what happens here is you can see the value of x here is actually power of 1, correct? So usually power of 1 we won't write, okay? So which means that it is actually, after you integrate, it becomes x, all right, 1 plus 1, okay, over 1 plus 1. Okay, so in another method, if you want to write it, is n plus 1 over n plus 1. Okay, So that's what happened here. So that's why it becomes x2 over 2. So if it is here x2, then it is 2 plus 1 over 2 plus 1. Okay, that's why it becomes x3 over 3. Okay, so these are very simple laws of the integration that you just have to remember, right? And then of course, when you have reciprocal, right, you integrate 1 over x, then you get ln x. Okay, and another important one is the exponential, integration. Okay, so when you integrate your exponents, ex dx, then you will get back ex. All right, okay. And then of course, if you have a number x and then you have ax over ln a, and of course ln x then becomes x ln x minus x. So these are all very basic laws of functions of integration that you should know already by now, right, at this level. Okay, so let's go into just okay. So going into a little bit on the rules of logarithms, all right? So all these are just some information, prior informations that you need to know before you can attempt your questions, all right? Your chemistry questions, okay? So here you can see you have to remember the basic of your logs, okay? Log 1 equals to 0, log 10 equals to 1, log 100 equals to 2, okay? If you have log 10x, then it is equals to x. Log ax, then you get x log a. Okay, and then you have your ln. Ln 1 is 0, ln e is 1, ln ex is equals to x. Okay, so you have to remember this part lah. All right, and also ln ax equals to x ln a. Okay, and if you have your log ax over b, then it can become, you can actually remove the parenthesis to outside, okay, and then you have your x outside, and you can bring down the x to simplify the equation. All right, and when you have log ab, which is actually times, then you have log a plus log b. All right, and then log a over b is log a minus log b. Okay, so again, all these are very basic information that you need to know, all right, in order for you to be solving questions later on. Okay. All right. So going into our lesson today, all right. So we want to be looking at the first order rate law. All right. Okay. And in the first order rate law, you actually want to write out negative dA over dt. Okay, where you want to read the changes in the concentration of reactant A over time. Okay, so this is equals to Ka. Okay, so this is your very common expression for your first order rate law. All right, and then you want to rearrange. So when you rearrange, what you need to do in order to use the integrated rate law is you need to rearrange so that your dA and your A is on the same side. Okay, so in another way of looking at this actually appears as, okay, this actually appears this way. All right, here, this one. Okay, so in that way, you know what are you actually integrating. So when you integrate, you actually integrate from A naught, okay, which is your initial concentration, until a value of A, okay, the concentration. Okay, so this is what is happening here. All right, so you have to be able to see this lah. All right, so equals to negative K dt. So and dt as well, you're actually integrating from TO, which is your initial, the time 0, until a certain time. Okay, so when you integrate this expression, okay, when you do the expression, okay, when you're able to arrive at this expression, you'll be able to write out, okay, using the integration law just now that you learned, right? Negative ln A over AO equals to KT. Okay, so from here, okay, because this is A over AO, so that means it's A minus AO. Okay, so you can actually rewrite this whole expression. All right, when you rewrite the whole expression, it's actually ln A minus ln AO. Okay, all right, so you can then solve this, all right, in order to get ln AO minus ln A equals to KT. Okay, now from here, you can further rearrange this equation. Okay, you can further rearrange this expression to become negative ln A equals to KT minus ln A naught, right? And for the finally, okay, you will arrive at this expression where ln A is equals to negative KT plus ln A naught. Okay, so from here, what you can see, the similarity between this expression and your normal straight line expression is, okay, your ln A is your y, all right? Your negative k is your slope, your t is your x, and your ln A naught is your intercept. Okay, so which means if you were to plot the graph of ln A versus time, you will get a linear graph, all right, with a slope negative k and intercept at ln A naught. Okay, so this is the graph that you will get from your integrated rate law for first order reaction. Okay, so I repeat, when you want to solve a question that has a first order reaction, okay, if you were to plot a graph of ln A over time and you get a straight line with a negative k slope, then this is a first order reaction, okay, with respect to A. All right, so or you can also plot ln A over AO versus T. Okay, now if you were to plot the graph, okay, in the other way around, okay, where it is ln A over AO, okay, versus T, you can actually get a straight line where the K is a positive slope. Okay, which this one actually comes from this part here. Okay, so depending on what expression are you using, whether you want to use ln A equals to negative k plus ln AO, or you want to use ln A, all right, linear graph with slope of k. All right, okay, all right. Okay, so moving on, all right, moving on. Sorry, it's supposed to be negative k, not positive k. Sorry, my bad. Okay, it was supposed to be a negative k. Okay. So if you were to plot this graph of ln A over A naught, over T, okay. Okay, so it can give you a negative k slope. Okay, all right. Now, if, however, you take this expression, all right, you take this expression and you exponent both sides, all right, okay. If you put an exponent on both sides of the equation, you can actually arrive at another expression where it is A over A naught concentration equals to E power of negative KT. Okay, or if you were to rearrange this expression, you will get A equals to A naught exponent power of negative KT. Okay, so the concentration of the reactant governed by first order falls off from an initial concentration exponentially with time. Okay, that's what this expression means. All right, but you only use this expression for first order kinetics that are has exponential decay kinetic. Okay, and this is usually done for radioactive decay of nuclides. Okay, so this particular rate law is used for radioactive decay of nuclides. Okay, so unless your question states that it is for radioactive decay, only then you use this expression. If not, you use your usual ln A, right? The one that we looked at just now, negative KT plus ln A naught. Okay, so from here you should know that two things, okay, that we have learned so far. All right, one is how to arrive at this equation. Okay, secondly is your graph. Okay, if you were to plot ln A, okay, versus time, all right, you will get your slope, okay, which is a negative, all right, and you will get the intercept at A naught. Okay, ln A naught is your intercept. Okay, so these are the information that you will be able to achieve when you use your integrated rate law method. Okay, now let's look at okay, now let's look at one example, okay, on how we actually can draw your graph, okay, and what are the information that we can get, right? So in this first order reaction example, if you look at the table here, okay, you have your time 0 until 600, and then you have your concentration of H2O2, all right, and they have already given you the ln of this concentration. Okay, so usually your questions won't be this simple, but this question is just to show you how you can plot your graph and how you can actually find the corresponding information from the graph. Okay, now what I want you to do now quickly is, okay, you can start looking at this graph. All right, this is already told to you, it's a first order reaction example. All right. The question already told you it's a first order reaction, okay, and they have actually shown you but this one usually you have to plot yourself. All right, either you use Excel or you use Graphmatica. All right, as I've shown you earlier, so you can now actually take your time to try to plot this graph. All right, now what I want from you is find me the slope of this graph. Okay, find me the slope of this graph. Okay, can you guys quickly do it? I give you 5 minutes to find the slope of this graph. All right, and let's have one person to volunteer to give us the value. Shall we? Can we have one person to volunteer? I give you 3 minutes. Can you come up with the answer? It's very simple. Everything is there. You just need to look at the diagram and what do you call? And give me the values of the slope. Okay, and when you give me the value, explain to me how to calculate the slope. All right, 5 minutes. I would like to have a volunteer. Remember the coffee coaster? Okay, it's still up for grabs. Okay, anytime you're ready, you can just volunteer yourself to answer. Okay, can we have someone from the class quickly to answer? Right, you can answer in Bahasa, it's okay. Maybe Muhammad Riwaldi or Fauki, Nopita, somebody from the class? Come on guys, give me one answer. It's very simple. Or Valencia. Nobody wants to answer. Nobody wants the coffee coaster. You don't want it? It's 3D printed, huh? Anyone? Or you don't know? But it's just finding the slope of the graph, huh? The graph is already there. You just have to find the slope. No one wants to answer. How about Barik? Barik? Or Akib?
Doctor, I'm sorry, I haven't found the slope. Can I get struggle?
Okay, can you try first?
I have tried, but I can get equation about equation line. So
you can manually calculate the slope. You don't know how? Do you know? You have to draw a triangle to the straight line. Okay, never mind. Maybe I should show it to you guys, all right? Okay, never mind. Let me just show you in case you are not sure, huh? Right? So when you have your graph like that and you're supposed to look for the slope of the graph, okay, what you can do is you can draw a straight line, okay? Okay, you draw a straight line to form a triangle to the graph. Yeah. Okay, my line is not that straight, huh? But you have to draw a straight line to the graph. Okay, so what happens from there? Once you have drawn the straight line through the graph, you want to get the value of here, which is now it is negative 1.5. Correct? The distance from here to here is negative 1.5. Okay, and the distance from here to here, okay, maybe it's not very clear because it's already cut up to here. So I'm going to just give a ballpark figure of 510. Okay, and here it is 100. Okay, so which means the distance between here to here is 410. Okay, can? So the slope is, all right, when you want to find the slope, then it's negative 1.5 over 410. Okay, m and second. Okay, and this will give you the answer negative 3.7 times by 10 power of negative 3 m as negative 1. That is how you calculate the slope. Okay, so if you actually do it in Excel, you probably will be able to get exactly, you can read what is the value at this point, or also if you do it in Mathematica, you can actually read the exact value lah. So I'm just giving a rough value because here to here is 500 to 600, so it's probably about 510. Okay, all right. So that is how you actually find the slope. You take the y value, you over the x value. Okay, and do remember that you will get a negative value because the graph is going down, right? Okay, all right. Now, okay, so I hope you can understand that, all right? Okay, so let's look at another question. Just now, that was a question that involved the graph, okay? So sometimes you are asked to draw a graph from the data that is given. They might tell you that it is a first order reaction. If they tell you that it's a first order reaction, then you know what is the expression you should be using, and you should know that you should use ln A versus T. Okay, that is the first order expression. Okay, now if some of the questions might not give you the data and might not ask you to plot the graph. So in that instances, the question can also be like this, all right? Say for example, this question, the decomposition of N2O5 is first order reaction. Okay, so you have 2N2O5 decomposing into 4NO2 and 2O2. Okay, so they gave you that the kinetic constant of this reaction at 45 degrees is 4.80 times 10 power of negative 4 as negative 1. Okay, so they already tell you, okay, sorry, okay, so they already tell you that your K, okay, they already give you the value of your K constant, all right, 4.8 times 10 power of negative 4. Okay, now they are telling you that if the initial concentration of N2O5 is 1.65 times 10 power of negative 2 m, what is the concentration of N2O5 after 825 seconds? Okay, so that means this is your N2O5 initial concentration. Okay, so remember your expression ln A equals to negative KT plus ln A naught. Okay, always remember this. All right, so they already tell you it is a first order reaction, so you must know how to write out the expression for your first order reaction. Okay, so let's try to solve part 1 of the question. Okay, all right, so using the expression, okay, using that expression that you have learned just now. Okay, so you have your ln N2O5. Now, but this one, now they are asking you at 825 seconds. Okay, they have specified your time. Okay, they have specified your time to be 825 seconds. Okay, so equals to negative KT plus ln N2O5 and naught. Okay, so now what you need to do is just plug in your value of K that they have given, but now it's a negative K of the value times by your time is 825 seconds, which is asked in the question, plus by your initial concentration, which is your ln N2O5 naught, okay, which is given in the question. So when you plug in all the values into the expression, okay, and then you will get ln N2O5 825 seconds, right, is equals to negative 4.5. Okay, and then when you use your calculator, all right, and you calculate the value, you will get the concentration of N2O5 is 825 seconds equals to 1.11 times 10 power of negative 2 m. Okay, so from here you can see the most important thing that you need to know. Okay, I'm repeating it again, right? Because you have to remember this expression by heart. Okay, you have to remember this expression. Okay, so this is what is happening here. All right. Okay, so that is for part 1, right? So let's look at part 2. Okay, part B. So in part B, what you are asked is, how long would it take for the concentration of N2O5 to decrease to 1.00 times 10 power of negative 2 from its initial value? Okay, so just now they asked you to find the ln N2O5 at time 825. Now they are asking for the time. Okay, now they're asking you to calculate the time. Okay, so for question 2, they're actually asking you for the value of t. Okay, so they already gave you your ln N2O5. Okay, value of your N2O5 they already give you. Okay, your your A naught or your initial concentration is here. Okay, and your K is here. Okay, so you just need to plug all of this, plug in all of these values into your ln A equals to negative KT plus ln A naught. Okay, so by now I already mentioned the same expression. I already write out the expression so many times, which means all of you need to understand or remember that this is the expression for your first order integrated rate law method. Okay, and you must know how to draw the graph as well. All right, so let's now try to plug in the value and we try to solve for t. Okay, so you can see here they have actually plug in the values for ln. All right, okay, that's given in the question, and then this is also given in the question, right? And you know the value of k. Okay, and when you solve, you will be able to get 1044 seconds. Okay, so this is also another quite simple question, but you can only answer it if you remember the expression. Okay, so that's why it is important for you to remember that for your first order rate law, for integrated rate law, that is the expression that you need to remember. Okay, so now let's go to, that is your integrated rate law. Now, why I jump straight to the half-life method is because when you usually when your questions come out, right, it will be a combination of your integrated rate laws and also your half-life methods all in one. All right, so you must be able to connect, okay, between your first order reaction and your half-life method for first order. Okay, so like I mentioned at the start of this the lesson, today we are going to learn two methods for first order, which is the integrated rate law method and the half-life method. Okay, now moving on to the half-life method. Okay, before I go on, let me just add one typo here. You need to change in your in your notes. For half, okay, there is a missing word here. It should be half. Okay, all right. So what do you mean by half-life method? Okay, basically you want to examine the behavior of the half-life as the reaction progresses. Okay, what this means is, let's say you have your initial concentration of your reactant. Okay, half-life is when the initial concentration of your reactant falls half to its original value. Okay, so the time at when your initial concentration of your reactant fall to half of its original value, that is known as the half-life. Okay, so the measure of the half-life is actually depend on the concentration, and the expected behavior can be predicted using the integrated rate law that you derived earlier. Okay, so that's why it is quite interconnected with the integrated rate law method. Okay, so using the definition of half-life, at time t-half, the concentration A drops to half the original value, okay, of the AO. Okay, so putting that into an expression, which means at half-life, right, at t equals to t-half, so half-life usually we write it as t-half. Okay, this is the meaning of half-life. Okay, so at t-half, your A, the value of A is half of A naught. A naught is your initial concentration. Okay, so half of A naught is the concentration of A at half-life. Okay, so this is the meaning of half-life that you must remember, must remember. Very, very important to remember. Okay, for your first order rate law. Okay, right? So now, T-half is the time taken for the initial amount of a reactant to fall to half of its original value. Okay, so T equals to T-half, right? So C, you can either, C is actually referring to the concentration. So you can either write it A or in the square brackets, or you can also represent it as C. Yeah? So here we are representing as C. So C is equals to C naught over 2. Okay, again, I repeat, C naught refers to the initial concentration. C refers to the concentration at T-half. Okay, so when you substitute this into the first order equation, okay, again, please try to remember what is your first order equation. Okay, negative K, all right, negative K plus ln A naught. Okay, please remember again, I write don't know how many times, I think about 5-6 times today, all right, the same expression. So you put the values inside here. Okay, when you put the values inside here, so it becomes ln C equals to ln C naught minus KT. That means there is a rearrangement, right? So you just take ln A minus with KT, all right? Okay, so from there, all right, you know that your C, okay, now you substitute this into, substitute this into here in order to get this, right? So your C becomes C naught over 2, right? And then your C naught remains, and then your T becomes T half-life. Okay, so if you solve this part, all right, if you solve this part, okay, just to show you, C naught, right, minus with ln 2, okay, remembering all the rules of the ln that we learned at the start of the lesson. Okay, T half, all right, so the ln C naught will disappear. Okay, you are left with negative ln 2 equals to negative K T half. Okay, so you solve it, all right, you solve this, then your T half becomes equals to ln 2 over K. Now this expression, okay, this expression is unique to first order. Okay, is unique to first order. All right, so now you know for first order, all right, integrated rate law, okay, we have learned for integrated rate law is ln A, okay, equals to negative KT plus ln A naught, and the second one is your T half-life is equals to ln 2 over K. Okay, so far this is the information you have learned from today's lecture. All right, so now is to make use of this information to solve the questions. Okay, so now you know what is the meaning of all the expressions. All right, so let's try to solve the question after this. Right, so you can actually represent your half-life for the first order in the terms of a graph also. Okay, all right, you can also represent your half-life in terms of graph. Okay, now if you want to know whether your data, let's say you're given a range of data and you're not told what is the order of reaction. Okay, you can also use the half-life method to know whether it is first order. Okay, so if it is a first order reaction, okay, when you plot the graph of concentration against T, okay, now it's concentration, yeah, it's not ln A, yeah. Okay, for half-life method, we want to plot concentration over T time. Okay, you will get a graph that looks like this. Okay, and if, all right, if you try to study the drop, okay, in half of the concentration, and you read the graph, okay, and from C naught over 2, drop another half to C naught over 4, and you read the time, okay, you draw a straight line, and then you read the time, and you draw a straight line and you read the time, you will find that T1 is equals to T2. Okay, you will find that T1, right? So that means the half-life, the time is constant. Okay, so that means the time for your original concentration to drop to half of its concentration, and for the half of the concentration to drop to its half of the concentration, the time is the same. Okay, and that means this is your first order reaction. Okay, so time taken for the concentration to decrease from C0 to C0 over half, and the time taken for the concentration to decrease from C0 over 2 to C0 4 is the same. Okay, so when you have this, then it is actually your first order reaction. All right. Okay, now let's go into the question. Okay, how you're going to apply all the information now that you have learned into a question. Okay, so earlier we saw for the integral method, okay, you're using ln A equals to negative KT plus ln A naught. Okay, so you are drawing that graph. Now you want to use the half-life method. All right, so you can see that in the graph. Okay, you can see that in the graph, in the question, the data below refers to the following reaction. 2A decomposes into B plus C. Okay, so you have your table here, right? So you have your time 0, 40, 80, 120, 160, 200, and 240. Okay, and your concentration, okay, in the table here. So plot a graph of A against time. Okay, and use your graph to determine the order with respect to A, the initial rate, and also the rate constant. Okay, so now what they have done is they already tell you what is the graph they want you to plot. Okay, so if you have this kind of question, you can already suspect that you are using a half-life method. Okay, you can already suspect you're using a half-life method. So you should know first order half-life, T1 will be equal to T2. Okay, so that is already something that you already know. So you can use that information to solve this question. So let's look at how we're going to solve the question. Okay. All right. So now this is the question that we will solve together. Then later we will, I will give you time to you guys to get into your groups and try to solve 2 other questions. And we will discuss the answer after that. All right. So now, for now, let's look at this. Okay, from the graph, okay, now that you already plot the graph, you will get this line. When you plot the graph, you get this line. Okay, so from the graph, you know that your initial concentration 0.8. So 0.8 drop to half is 0.8 divided by 2. So which is 0.4. Okay, now, so from 0.4, you draw a straight line, okay, to touch the graph, and then you go down and you read your first T1. Okay, okay, so you get your first T1 is 80 seconds. Now from 0.4 you drop to another half, so 0.4 divided by 2 is 0.2. So you draw another line, okay, until it touches the graph, and you drop down. Then you get T2, which is also equals to 80 seconds. So from here, you already know T1 equals to T2 is 80 seconds. So the half-life is constant. If the half-life is constant, this is first order with respect to A. Okay, very simple, huh? Because this particular half-life that we learned today is only unique to your first order reaction. Okay, so that's how you solve the question. Okay, we will look at how it will look like for second order and third order later on. Okay, in your next week's class. Sorry, for second order and zero order, we will see that in next week's class. Okay, now for the second part of the question, initial rate. Okay, so initial rate you already know 0.8. Okay, 0.8. So you draw your tangent. This one we learned from your previous lesson. Huh? Okay, so the initial rate. So you draw a tangent. All right, and then you just calculate the tangent, the triangle at your tangent. Okay, so this is about 110. This value here is about 110. Okay, so the initial concentration is 0.8. So you divide by when it touches the x-axis, right? So you can draw. You can also draw it lesser, lah. Okay. You can also draw it until here. Okay, but I like for me personally, I like to draw it up to it touches the what you call the x-axis, because then it's easier for me to read the value of x. All right, and also it's easier because it's just 0 up to 0.8 and it's 0 up to the point at which it touches the x-axis. So it's easier to calculate with less mistakes. All right, so when you calculate that, you'll get 7.27 times 10 power of negative 3. Okay, now for the final question, okay, I there's a typo here. I need you guys to just in your notes, just ignore this part. This one is not, this is not. Okay, in fact, what we have derived just now is T half is equals to ln 2 over K. Okay, now that you know that from the first part of your question, this is a first order reaction with respect to A. So when you want to find the constant K, you can use this expression. Okay, so if you find ln 2, the value of ln 2 is 0.683. Okay, so it is a constant value lah. So for first order reaction, T half is equals to ln 2 over K. So the ln 2 value is 0.683. From here, you know that the T half is 80 seconds. From your question, you know your half-life, the time of your half-life is 80 seconds. So from here, you can just rearrange and you will get this value as your constant. Okay, so quite easy if you understand and remember whatever that you have learned so far. Okay, now moving on. All right, so let's look at these two questions. Okay, one thing in your notes, I just realized I actually pasted the wrong question 2. Okay, if you see, I accidentally paste this as your question 2 in your notes. Okay, I just realized it just now. Okay, when I was double checking the notes. Okay, so your question 2 it should be here. Okay, can you guys take a few seconds to just snap a picture of your question 2, because now you will be going into your groups. Okay, as usual, and I want you to solve these two questions, and I will choose two groups to present the answer. Question 1, one group. Question 2 will be another group. Okay. So Dr. Gallo, if you can help me to prepare the students to go into their respective groups. All right. Thank you.
Yeah, sure. It's going to be 10 groups, or we actually have only 58 participants. So I don't know, should we just open 8 rooms probably?
Can, Doctor? Can. That should be okay.
Ya, seperti biasa Anda pilih sendiri grupnya ya, ruangannya pilih sendiri, ruangan 1 sampai 5 untuk mereka yang memang mengontrak mata kuliah ini ya. Kemudian untuk grup 6 sampai 8 itu untuk yang sit-in ya.
Okay, Doctor, thank you.
Okay, I already opened all the rooms. Please choose your rooms, okay? Room 1 to 5 is are for those that registered to the to this course, and then room 6, 7, and 8 are for those who sit in. Okay.
Remember to take a picture of question 2, yeah?
Ya, jangan lupa untuk capture dulu soalnya. Don't forget to capture the question or discussion.
Excuse me, Dr. Sangi.
Yes.
I want to ask about the question. One is for what group in that you explained before? Question
No,
one.
I will tell later. So both groups will have to answer both questions. I will let you know later. Which
Oh,
questions
okay.
that you
All right.
answer.
Okay, doctor. Thank
Yeah,
you.
you have to answer both questions.
Yeah, so probably best to capture the screen for now, so you can have both questions.
Too many in room 2. Huh?
Oh, really?
Yeah, never mind. I'm changing their groups.
Okay, okay, sure. Thank you, Doc.
They all want to be with their friends. Huh?
Yeah. I try to remove some students from room 8 as well, because too many of them.
Is all our students in today? Because I feel like there's not enough. Okay.
Barik, do you have problems? Oh, okay. Already joined other groups.
Okay, I think everyone already joined in the group.
Yeah.
So, Doctor, I will send the coffee coaster to you today.
Okay, sure.
To your
So
mail.
I'm not sure how long it usually takes for sending things from Malaysia to Indonesia. Have you?
Not
do you
sure.
have
This
any
is my
experience?
first time. This is my
Yeah, yeah.
But I think we'll probably use. I'll send you the code, the courier. Once I've sent it.
Yeah, yeah. So I can track it.
You can track it. Yeah. Just to encourage them to take part.
Yeah, yeah. I think it's a good idea.
Too quiet. But it's the same with the Malaysian students. So yeah,
I'm not sure though if it's still about the language barrier, but I think we need to make students used to it as well, because it's important for them to.
Yeah, like I said, I don't think it's the
used to
language problem, because here in Malaysia we also have the same problem with the students. They
okay.
Yeah. Even if you call their name, they just keep quiet. I think it's more of Asian students problem. I don't know.
Yeah.
They are so shy to speak up.
Yeah, it's our problem. Wita Rosa bisa masuk ke grupnya?
Ya, Bu, mohon maaf tadi sempat kelempar.
Okay.
I give them another 2 minutes or so, then I will go and check on them.
Yeah.
Okay, so group 1, as I told you in your small group just now, I hope you're ready to present your answer. Okay, you can start by sharing your screen and you can present your answers. All right.
I'm sorry, Doctor. We're not ready yet.
Not ready yet. Just now you already done your question?
No, because we understand how to find the tangan line.
For group, question 1.
Yes. For the question 1.
Have you drawn your graph?
Yes, but we were not. We can find the
Slope.
line. Should we find the tangan line?
For question 1, you just need to find the slope of the graph. Are you able to find the slope of the graph?
Not yet.
Can you show me the graph? Can you present your graph?
Okay. Wait. This.
Okay, so you want to find the slope of the graph, right? Okay. So how do you do it? How do you find slope? You draw a triangle between two points. Okay, you can do that. Okay. Is that okay?
Hey, Doctor,
Yeah.
click on this chart
Yeah.
or graph from logarithm natural on their data. Okay, Doctor. In time 0, the concentration is negative 0.14, and in times 10 mean negative 0.28, and dan seterusnya.
Yes. So from here,
So from
this
here we find this chart, Doctor.
yes. Okay. So the second part of the question is you want to find the constant, correct?
Yes, Doctor.
So in order to find the constant, you need to draw a triangle, okay, to your straight graph here. Okay, you can draw at any point. Okay, you just need to find a triangle. Okay, remember just now I told, then you take the value of y over the value of x. Remember the example that I showed just now? You just draw a triangle to the line. Okay, you don't have to use illustration. Yeah, you can though. Just draw. Okay, can. Just draw a triangle. Okay, until right. Can. Then you draw another line. Okay, until the end. Until you touch the line. Yes, correct. Okay, so then you just take the y value divided by the x value. That is your slope. Yeah. Okay, so you have -4 to -1. What is the space there? That is a -3, right? Correct?
Yes, Doctor.
Yes, Doctor.
So -3 over, here is 50. This one is 250. Let's say we can say that is about 252. Okay, so -50. So it's, you take the value of y, you divide by the value of your x. Okay?
Okay, Doctor.
Yeah, so it's simple that way. So do it properly, and then you will be uploading into your Padlet. All right,
Okay, Doctor.
write it out nicely and then upload to the Padlet, including the answer for question 2. All right. So can we have group 4 to present question 2?
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you. So for the question, while group 4 is preparing for question 2. So for the question 1 just now, okay, it was actually trying to trick you, in the question, if you read properly, they say use a graph to show what is the order of reaction. So that is how usually question will sound, okay? So it is up to you to prove what it is, all right? So in this instance, because today we are learning only the first order reaction. So if you take your ln A and you take the value and then you ln the values, all right? And you plot ln A versus T time, okay? And you will get your straight graph from there. You can actually know that it is actually referring to your first order reaction, okay? So as we said earlier, the slope of the graph is your rate constant, okay? The intercept is your initial concentration, all right? Okay, so can we have group 4? Group 4, quickly.
Oh, okay, Doctor. We will share our answer
you.
for the number 2, maybe.
Yes, thank you. Thank you, Melinda.
Okay, Doctor, I'm gonna search right now.
Okay, please go ahead.
But okay, this Doctor. We have make the graph in the Graphmatic. So it's the result for 100 minutes. It's for the 45.
Barik,
Okay.
Barik, can you make the picture bigger because it's quite blurry? No, maybe you increase the percentage at the bottom there. Yeah. Better. Okay, that's better.
It's for 450 minutes.
Right.
It's to draw the timeline. It's for 100 minutes.
Yes, nice.
So for the rate reaction, we have this.
Okay.
And for the second one, order reflection is the second order, Doctor.
How do you come up with second order reaction?
Because Fogi, can you help me to explain the second one? Hello.
Yeah.
Sir, can I please? Can I
Yeah,
speak
sure. Yeah, sure.
Jadi kan nomor A itu dicari rate of reaction. Berarti dengan artian bahwa kita harus mencari kecepatannya gitu, kecepatan dalam 100 menit dan dalam 40 menit. Nah, jadi kita tuh gak sempet sampai ngeplotnya. Jadi kita langsung aja cari konsentrasi dibagi dengan menitnya gitu. Jadi tadi konsentrasi dalam 100 menit itu 0,6865 dibagi dengan menitnya itu 100. Jadi 0,006865 molar kali menit pangkat min 1. Mungkin gitu.
Fauki, you're answering part 1, is it?
Yeah, no, question 2, part 1. Yeah.
Okay, actually for part 2, the answer is wrong. Huh? Okay, so if you remember how we were to, let me share the notes for a while. Yeah, let me show you for a while. So what you're supposed to do is you're supposed to take the initial concentration, you divide by 2, and it will drop. Okay, so in your instance, your concentration is 1, correct? Your initial concentration of sucrose is 1. Okay, so 1 divided by 2 is 0.5. Okay, so you're supposed to draw a line from 0.5 and then find the time. Okay, then 0.5 you divide by 2 is 0.25, and then you draw a line to 0.25 and then you drop down. Okay, so then you will see that the time T1 and time T2 is same or almost the same, then it becomes a first order reaction. Okay, that's what you're supposed to do actually. All right, so can you share back your screen? Okay. Can you share back your answer just now?
So, okay, doctor. So,
Okay,
like,
can you share again? Let me take a look.
so in here, doctor,
Yeah,
we
correct.
should divide 100 with wait
No, you don't need to
0.6
divide
with
by
100.
100. No, we are talking about part 2, Farid.
Oh, part 2. Okay.
Yeah, not part 1, not part 1 anymore. We are talking about part 2. Okay, so if you go up a little bit, how do you find the order of reaction? You go up. Okay, so you need to find the initial concentration. What is the initial concentration? Okay, and then you need to divide by half. So initial concentration is 1, correct? Am I right?
Yes, doctor.
Correct.
Yeah.
So 1 divided by half is 0.5.
Yes.
Correct. So you will look at here, so 0.4 to 0.6, right? At your y-axis. So from 0.5, you draw a line, straight line to touch your graph. Okay. And then you go down. Okay. So that is the first T half, your T1. All right. Your T1. Okay. Then from 0.5, you divide by 2 again, you become 0.25. Okay, so at 0.25, you draw another line. Okay, no, it should be above, but it should be above.
Right. Okay, doctor. I'm sorry. Okay.
0.25, and then you draw a line to touch your the graph and go down. Okay, so the difference in the time, okay, it should be the same, same or almost the same. I think you will get 180 for T1 and 190 for T2. Okay, so it's almost the same. So this is a first order graph. That's how you.
It's the first order. Okay, doctor.
Yeah. Okay. So part 3.
For the
Haven't done. Part 3. Where you ask for your T half.
For the rate constant, doctor.
Yeah. So if you know the rate constant, okay. So if you know the rate constant, you can what do you call calculate. Yeah, sorry, if you know the T half, right, just now, correct? Now, just now we find T half, right, in part 2.
Yes, doctor.
Correct. So when you know the T half, you can calculate the rate constant.
Okay.
Correct.
Okay, doctor.
Because T half is ln 2 over K for first order reaction.
Oh, yes.
So if your T half just now is maybe slightly different, like I said, it should be 180 and 190. So you can take an average of that value.
So then when we can find the K.
Yes, then you can use that to find K. All right. Okay, so never mind. All right. You can unshare your screen first. Okay. So now that I've explained to all of you roughly how to solve the question. Okay. So you please solve both the questions, write out nicely and upload to Padlet for this week's assignment. Okay, Can you guys do that?
Yes, doctor.
Okay, thank you. All right, so with that, we will end for today's class. I've also uploaded the question 2 into Padlet, all right, just now. Okay, so you can refer to it. And if you have any questions regarding on how to answer. If you don't understand, you can always drop me a message. All right? Okay? Okay? Okay. So
All right, Doctor.
okay, if there's nothing, then we can end the class now. Thank you, everyone.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
You.
Thank you.
Thank you.
Thanks, Dr. Gallo. Thank you.
Thank you.
Bye-bye.
Thank you, Dr. Sangeetha. Thank you, Dr. Galu.
Bye.
Bye.